Well, thank you for your patience. I don't know if you could see the bullets of sweat running down my face there for a moment as the slide deck mysteriously disappeared. And we're okay though because the title is wrong. It's an earlier version of the slides, but the agenda is good. Okay, so my name's Kevin Klein. I have to go very quickly today, so I apologize. We'll have to hold all questions till the end. This is originally a 60-minute presentation that we're going to cram into that 50 minutes, and so there's a lot of good content, and I'll need that time to roll through effectively. Um, I've worked in the industry since the middle 80s. I was a really good Fortran programmer, and I also knew how to write a select statement. Woo, that was crazy back in 1986 and 87. And I was able to get a job working for NASA building the life support system in the International Space Station. We used Fortran plus SQL because they hadn't invented stored procedures yet, which sounds like a pretty weird thing to say. It seems like we've always had stored procedures. But written a lot of books over the years. I wrote the first book on Transact-SQL back in the early 90s. My bestseller is SQL in a Nutshell. I'll be doing a book signing tomorrow at the O'Reilly booth for the 4th edition, which was newly updated last year. So I believe they have 25 books they'll be giving away. And so if you want to arm wrestle to get one of those, I think it's first come, first serve. So what are we going to talk about today? After NASA, I also spent some time working for the US Department of Defense, but later on I went to become the, the lead for database management at one of the big four accounting firms, you know, Deloitte, KPMG, and so forth. So I was at one of those firms, and all through the 90s, we wrote our own apps because there weren't a lot of apps you could buy back then. You could buy big multi-million-dollar ERP systems, but you couldn't do much more than that. And so the management team asked me, now that we are in the early 2000s and we have the web 1.0 kind of revolution that started to happen, you could buy apps for all kinds of different purposes for the first time. And so we started to go through the process of buy versus build analysis. And one of the things that you started to hear in 2001 and 2002, vendors would say our product runs equally well on Oracle, on SQL Server, on Postgres, on MySQL. And what in fact they actually meant was our product runs equally crappy on Oracle, SQL Server, MySQL, Postgres. And so way back then, I wrote the first set of scripts that I would use to just give me a general idea about the code quality. For example, do they have indexes? It's very common to find that there is no or next to no indexing on a database application made for commercial use. The other thing that you would find over time too is that there were consistent inconsistencies. Like you could tell that this module of the application was built by one group of people who had different naming standards than another. So this is problematic. You would also find situations where you could see that some of the developers, oh, I see that in this stored procedure, this particular person writes very good code. Another person writes very poor code. And so this was very useful for us to not only gauge the quality of the code from companies that we were purchasing software from, it was also really useful for support situations. Because sometimes, even though the code quality wasn't great, functionally, it was so good in terms of the functions it provided that we still chose to go with that particular product. But that's not the end of your relationship with that vendor. Now you have, in our case, we'd have $40,000, $50,000, $70,000 support contracts. And so by conducting a review like this, I, as the lead on the database team, a similar person from our dev team, infrastructure teams, could come back and say, do you want us to pay this support? $70,000 is not an incidental amount of money, not pocket change. So here's some things we want to see on your roadmap to improve. Like, we really need primary index. your primary keys, right? That's kind of a thing. Um, and so it was very helpful for us. So what I would like to ask of you too is you look at this, we're going to spend most of our time in some demos. And as you look at the demos for the different kinds of smell tests that we are going to do, think about how you would automate this. So what I'm showing you are discrete blocks of code, Transact-SQL code, to help us find a lot of these problems inside of our databases, inside of the database design, inside of stored procedures and so forth. And when I eventually managed to get this put out as a GitHub repository, then maybe you can help me take it to the next stage of making it something that we can automate. So why do we do that? Well, one of the things that we learned some great lessons from is that not only is it good for the big dollar products that we are buying from these different vendors, it was really good for our team. And maybe your environment is different than mine, but at that time, we had a little bit of adversarial relationship between certain developers and certain DBAs. Certain DBAs on the team, not me, never me, of course, who would say, oh, you developers, you're just cowboys. You want to roll out code. You sneakily find out ways to get with the SA password, and just roll out a change at 3 p.m. on Friday, the busiest Friday of the month. And then the developers would say, well, you're the DBA, you're the guardian, you're just no fun. You never want us to do what we need to do to get things done quickly. And we actually made it part of our process to sit down together. Now, keep in mind, this was during the waterfall era of development. It wasn't agile, but we became more agile the more we talked, right? And the more we worked with each other in a friendly fashion, the more we were able to respond quickly, to iterate through changes, and improve the overall quality of our own code as a team. Because when we would do a code review, the different developers who are writing Transact-SQL code would learn, oh, I didn't realize that SQL Server collects its own statistics. And so database was up and running for quite a while. It's got statistics on a column. And then we put an index on the column. And now we have duplicate statistics and indexes. That is actually an anti-pattern. You can have a situation where that doesn't perform as well as having one or the other. I guess I should also say too about the smell tests and so forth that I'll show you in just a moment is that it does vary a lot over time due to the version improvements in SQL Server. So the older the SQL Server, the more opportunities we have for these things to go awry, to go bad. But as SQL Server has gotten better, so has its ability to react to poorly coded stored procedures, triggers, user-defined functions, and those sorts of things. All right? So we're going to look at the code in a couple different ways. The first part I just call it step one, is we're going to look at the database in the way it is coded. There are lots of issues with indexes that we can just run some queries to see if those problems exist. There are lots of issues with data types. Like if you have a column, let's call it employee ID, and it appears in multiple tables, and someone uses a different data type. For example, if you use varchar in the employee table, and then in the a leave tracking table, track your time off, that is an invarchar. That will cause an implicit conversion, which means that it will not use any indexes on that particular column. It'll have to do a scan every time. They both have the word varchar in it, right? Microsoft, how can you do this to us? Well, it's because a varchar is standard encoding. Invarchar is Unicode, which is twice as many bits as standard encoding. So at a binary level, the values are not the same, even though Kevin, my first name, looks the same to our eyes as a human being. It looks like something completely different to the computer. So those are the kind of things that we're going to look for. Maybe old data types, maybe a database design that never uses varchar 100, varchar 500. It's always varchar max. Anyone seen that kind of application? It's like, why would you do that? That causes the engine to process your queries differently than if you give it a defined size, okay? Now again, these are not necessarily horrible things, but they can lead, like for example, if you do use varchar max a lot, it might be because that really is the most appropriate choice at the time. So the point is to produce a report of things that might be a problem. That doesn't guarantee that they are all of the things that it finds that they are a problem, but they might be a problem. And so it leads to the next set of questions that will give you an improved output from what the quality of the code is. So this is just a little bit of an overview. We'll spend more time in the demo looking at this as we run through it. The next part, looking at our Transact-SQL code, I do in two parts. And I'm sure some of you are very smart and you could do a better job than I have done, but I'm using T-SQL to evaluate T-SQL in the database designs. And so I've broken it into two separate parts. One is, what if the database has been running for a while? Pretty much all of you are probably, if you take these scripts and use them, you're going to use them on a database that has been up and running for a while. So there are a lot of things we can find out by pulling data from the plan cache, pulling data from other parts of SQL Server's telemetry, like dynamic management views, like X events. Maybe you might even use some special like DBCC commands to get additional information about how the system is designed and laid out. And so that's one set of code we will look at, the code that's actually running since the server was last restarted. There's also a pointer here for you about how to do similar sorts of activities using X events rather than the individual queries I'm going to show you. So if you would like to monitor on an ongoing basis for these things to happen, code in flight, let's say if you have a team that is putting out new releases frequently, you can use an X event to let you know if some new code has crept in that is causing some problems, okay? The other one we'll look at is code at rest. So just because we have a database that's been up and running for 3 months doesn't mean all the code that we have in the database has actually been invoked anytime soon. You know, we might have stored procedures that are only invoked at, say, a quarterly roll-up period where we add up a bunch of values, or maybe once a year, or only when certain people ask for it, like when the auditors come around. So we also want to be able to look at the code that is sitting in sys.modules, and we want to see if there's any particular anti-patterns in those as well, okay? And then just as a side note, I actually have a session later on about query store, just the very basics of query store. But there's a lot of wonderful things you can do with it, and it keeps getting better over time. So you can get a lot of this information. Even in some ways, you can get more information by using query store as well. Okay, so let's see, we're about 15 minutes in. So we might be able to get this done in time. All right. Forgive me for a moment while I pull up the demo. Coming through? Can you see SQL Server Management Studio? All right. So again, those of you in the back, are you able to see this as well? Yeah, okay, all right, great. I can't see it, and I'm standing a foot and a half from my screen, so I gotta get my readers out here. So one of the things that I will always check first is that there is a feature in SQL Server, and again, this is code in flight. So I believe this database really doesn't have much happening on it, but so a lot of these little blocks of code that we're going to run through are not really going to produce a lot of interesting results. But just to show you how it works, we're going to look at, for example, deprecated features. Uh, doesn't change a lot every year, but every time we get a new release of SQL Server, Microsoft tells us, here's something that we're deprecating. And deprecation, by the way, it sounds like planning to cancel is what that word sounds like. But what it actually means is, it doesn't mean we're going to take it out. It just means that if you call and ask for support, we might say, oh, yes, we've deprecated that particular behavior. Like if you use the old outer join syntax called a theta join, where you have the equal and the star, the really old format, they'll say, okay, we'll give you support, but rewrite that using the currently supported ANSI standard, ANSI ISO standard. Once you reproduce that using non-deprecated syntax, we will fix, or we will work on your support request. So don't think of deprecated as, oh, I'm running something that is a canceled feature that I'm lucky it still works. That's not really what it is. It means it's still in there. We don't plan to break your code, but we also will make you jump through some hoops before we'll fix it if we find a bug there, okay? So simply enough, we can look at the DM OS performance counters, and there's also a comparable X event. We look at DM OS performance counters for a particular SQL server, and for this instance, it will tell us how many occurrences and what occurrences have happened since the last restart for a particular set of SQL statements. So, for example, we have 26 instances of the old way to store visual imagery. All right, so instead of storing things in a var binary, we're using something like in text, or I'm sorry, something like image, okay, which the optimizer doesn't handle as well as it does with var binary. And so it goes through and tells us the various things that are happening. For example, what's wrong with sys users? We've got 8 occurrences of that. Anyone? Yes, Alan. It's the old way to name these things. Anytime you see sys with a full word and no period between sys and the word, you know it's old, right? Because everything, I guess probably since 2005, they started to move away and specifically define it in the sys schema, okay? So what's old-fashioned? And believe me, starting in the 80s, I get warnings for this stuff all the time because that's how I wrote the code when I was in my 20s. Now, another thing we like to do is make sure that we are using plans that could be query plans that could be reused a lot. And so this is a nice little query that tells us about the contents of the plan cache, that portion of the total available RAM to SQL Server that is used to store particular SQL statements. And so we can see what type it is here. We can see the text of the code here and how many times it has been used. Now, ideally, if it is prepared SQL, like a stored procedure, we would see a use count of greater than 1 in many cases. That means that the SQL Server is able to reuse code frequently. One of our moderators and I were just discussing how a particular set of code was written with more than 500, was it? 500 parameters. You're never going to reuse that plan, right? Because it has too many variables throughout. But ideally, we can write code that SQL Server can, rather than have to go through the whole optimization and compilation process, which takes a bit of CPU, hopefully it can go and take a look in the plan cache and find an existing plan that it could reuse. And so that gives us better performance. Another thing that I like to check for, we might get some questions on this online, but I want to know how many cursors that we have active. Not that I'm an enemy of cursors, but that cursors have their place. If you're in a role of administration, I believe DBA should be able to write as many cursors as they want. For example, if they're going to iterate through all the tables in a database or all the databases on an instance of SQL Server. However, what I'm looking for here is if these numbers are big numbers. That would indicate to me that this particular piece of software that I'm purchasing, maybe the developers all have an Oracle background. And in Oracle, they call a regular SQL statement, select statement, they call that an implicit cursor. And there's literally no difference for them between a select statement and a declared cursor. But with SQL Server, what do you have to do at the very end of your cursor statement? You have to close your cursor and then deallocate. You don't have to deallocate on a lot of other database platforms. So that means a cursor actually requires more resources than the same activity accomplished with a select statement, right? So what I'm looking for here is to see if their design principle is designed around explicit cursors rather than as needed cursors, right? So if they're doing everything as a cursor, that's an anti-pattern. If there's just a few in there, that's okay. All right. So this is a little bit more elaborate if you want some more information about the cursors that are being executed. We would see who under host name, we would see who is doing it, program name, who the client is, the login. Maybe it's just one person who has Management Studio and is connecting to the server, or one report writer, a group of people who are writing reports on the database that you didn't even know about. So this is a variation of the earlier query to show us more information about who the users are so that we can see what is happening there. In the same way, I have no problem with explicitly declared temporary tables, except when that's the main way the design team has approached using data, right? So they declare temp tables for everything they do. And that can produce a lot of churn in TempDB that can cause TempDB to grow a lot more than you might have planned for it to. And I think that this comes from developers not realizing that SQL Server uses TempDB for many of its normal organic processes. So for example, anytime you have an order by, SQL Server is going to build a work table or a work file in TempDB and then resort it there. Okay. Thank you. So Erlen, an MVP and a good friend of mine, says, no, not every time if there's a supporting index that works the right way. Thank you. I am a little prone to being too expansive. In fact, let me go ahead and say right now, there's probably an exception to the rule of everything I'm going to say in this presentation. There will be, for example, I have mostly worked through SQL Server 2019. I haven't used SQL Server 2022 a lot, and I bet they fixed several things that I might mention as we go along in the session. So thank you. If it's already in there indexed that way, and you have a order by a given index, then you can avoid this problem. But another example is we don't really usually pay attention to the join algorithms that SQL Server itself chooses to process a big join. And SQL Server chooses between three types of join algorithms. The most well-known is the nested loop. So it takes a value from table A, loops through table B, returns your result set. The next is called a merge statement. And think of this as, it's mostly used for tables of a comparable size with their, the join column being the same in both tables. And it's kind of like, okay, these are both 1 million records each. So we'll just kind of act like a zipper and compare that way up through the table or down through the table. And then the third is a hash. So this usually happens when the tables are both very large, but different, significantly different in size. Like this table has 200 million rows, that table has 20 billion rows. And so what we do is we build a hash of those, the columns in the join, and put that into TempDB. And there are some situations where the join column is also put into TempDB for merge. That's called a many-to-many merge join. So TempDB is getting hammered all the time, even if all you're doing is writing regular code and you're not actually saying create, table such and such, temporary table, with a pound sign. So I want to know not so much are they doing it, because it's okay to have a moderate and a controlled amount of temporary tables. But what we do want to know is this a major design principle for that particular application? So we can see the number, just generally, how many there are active temp tables at a given moment. And if this was a busy system, we might see that number change over time if we were to poll it from time to time. But it's okay if we have some. If we have as many as we do have tables or things along those lines, it can be an issue. So I do like to get an idea of that. In the same way, another thing I like to look at is how many hints do we have in use at a given moment. So we could take a look at the query optimizer system they don't call it system stored procedures anymore, showing my age again, in the DM exec query optimizer info. And so what we can do is we can see how many of these are actually in play at a given moment, like join or forcing order hints like that. Why would that be an issue? Well, the big reason this is an issue is because typically hints are written to solve a very specific problem at a very specific point in time. And so if you buy an app that was written for SQL Server 2016, let's say, and they found a way to make a query go a lot faster by putting a hint, the particularities of that query at that time may no longer benefit from the hint in the next release or the one after. So unless that vendor or your dev team is keeping up with the state of the optimizer, there's a good chance that you could needlessly be invoking hints that forcibly change the natural behavior of the SQL statement. And most likely, the result would be that you miss out on the performance improvements of the newest release of the database platform. So there's a potential for it to not necessarily make things a lot worse, although that can't say that that hasn't happened, but it's much more likely that it would prevent you from taking advantage of new opportunities that the newest releases provide for you. Okay. Another thing that is always good to check in an application is just generally how busy is it? And this is and if it is busy, in what ways? So this is a query that's been around for a long time. I believe if you haven't heard of it before, there's a Microsoft MVP named Glenn Berry, and he has this really good, he's kind of looked through everywhere across the internet to find the best kinds of diagnostic queries that are out there. So he aggregates them all together. And this query was originally written by a former Microsoft employee named Jimmy May, but it's so good that it has long outlasted his time at Microsoft. And what it does is it looks at all of your different SQL statements that are active in the plan cache, and it tells you, if I can make this a little bit bigger, it tells you basically how they score in terms of how many times they're executed, what's the average worker time, physical reads, logical reads, total worker time, and so forth. So you can get a good idea of who's the biggest consumer of memory with one query, who's the biggest consumer of read IOPS, write IOPS, and so forth. Not to say that this is your marching orders for tuning queries or anything like that, but this lets you understand the total scope of your workload. And one thing that's really great about it as well is that there's a number of order by statements that you can, according to what you care about at a given time, you can just change the order by to look at, if you know that you're thinking about replacing your disk subsystem and you care about IOPS, then you can switch it over to actual physical reads or logical reads. In this case, that's what I'm sorting by, is physical reads. You could instead look at the total worker time, which is the amount of CPU consumed by all of these different queries. Okay? So that's a good one to have. Another one is that SQL Server keeps track of all the queries that have a missing index warning that pops up. You may have seen that when you look at an execution plan, or you may have seen that in your error logs. And so let's take a look in the cache and see what we have here. Okay, so it looks like we have some, and I probably should change around to some of the other databases to see what we find there. But what we're finding is there's plenty of cases where we have seeks happening on a particular table, and a missing index warning has occurred there. Okay, so does that mean you should immediately apply the missing index? Notice in this script, it even gives you the code to replace or to create the index that it is pointed out as missing. Is it a good idea to just go ahead and apply that? Thank you for shaking your head no. I have faith in humanity now. No, do not blindly apply that. You need to look at it in scope of everything else, because every index you create also creates additional overhead. So on write operation, not on read, indexes help you with reads. But every time you create a new index, that means that SQL Server has to update all of the, with the write operations like inserts, updates, and deletes. It has to update the other columns, other index columns, so that the pointers stay accurate. And so it may help with one query, the one where it says it's missing, but it is by no means guaranteed that it will help with all of your queries. Or it might even, overall, if it's a table that has a lot of write operations, it might even degrade performance. All right, so we're approaching the end. This is the end of this particular set of code. So let's look at the next. Oh boy, we only have 15 minutes to go. All right, so I'll go quickly. So that's code in flight. Let's look at code that's just sitting there and hasn't been invoked for a while. So code at rest. Now again, there's nothing wrong here, nothing wrong with triggers. But what I'm looking for here is a situation, you can give triggers priority. You can say this is trigger 1, insert trigger number 1, insert trigger 2 and 3. What I'm looking for here is to see if I have any of those kind of stacked hierarchical sets of triggers on a table, because when things break, how easy is it to diagnose which of the triggers has caused my problem? It's hard. It's hard to say. In fact, I think a lot of people have moved away from triggers for that very reason. It's quite difficult to keep track of multiple levels and hierarchies of insert, update, delete triggers instead of or after sorts of triggers. So this is fine. This result set, I don't even have to study it. I've got zeros and ones. Good. If I have lots of 8s and 7s and 10s, that's not a good result. And this tells me the product I'm thinking about buying, or the team that designed it, they weren't thinking too clearly about what they wanted to do, especially in line with modern approaches to this code. Now, we're looking at cursors again, but in this case, not cursors that are currently active, but how many of the SQL modules is an expansive term incorporating stored procedures, functions, triggers, any of those prepackaged conditional code. And so in this case, we don't have any that we have in our database that are in, well, we have the 52 that we have created, but we don't have any more than that. What's wrong with select.star? Sorry? What's right with it? Yeah, that's great, thank you. I give DBAs leeway in a way that I don't with developers. It's always fine, in my opinion, to use select star for an ad hoc query every now and then for Management Studio. But when I'm putting it into code that's going to exist in production, I particularly demand this, by the way, for write operations, insert, update, delete. But maybe for data retrieval, it's okay. The problem is when that table gets changed somewhere down the line and more columns are added, if you have an insert statement that says insert to table select star, which columns are we talking about here? Because now we've got 2 or 3 new columns that the insert statement isn't thinking about because it says select star, right? But the table we're inserting to certainly is thinking about those columns, right? And that's my official term for it. SQL Server, of course, it's a machine, it doesn't think. But you want to make sure that you hard code every column into your inserts, updates, and deletes, that sort of thing. Merge statements as well. So use of identify, this is a very distinctly deprecated sort of call. Anytime you see the double @ signs, that means it's deprecated pretty much. They don't use that syntax anymore, okay? How about no lock? I've talked to developers where they say, well, our manager has said that every time we issue a select statement, we need to have a no lock on that. Yes. Yes. What's going on? The text in the results is always the same? Yeah, what is going on here? Total SQL modules, am I doing that such that it, yeah, total SQL. I think the percentage is missing from the lines. The like statement, thank you. So I don't, see, you've already improved my code here. Like this. I need one at the end. Oh. We're getting dangerously close to typing in a demo, which I don't know if you know this, but this angers the gods. Things break. Okay, so we're now at, thank you for that. So yeah, I need to come back and repair these queries, right? So let's do this again. And I have a subquery that is doing the same as well. Thank you. All right. Yeah, so I noticed that everything is coming up 52. What's going on here? All right, it's still 52. All right. So is it good to have no lock as a standard? I see some of you are gasping and weeping, right? Only if you don't like to have consistent results, right? Because when you use no lock, you can get very much variable answers from 1 second to the next in financial systems where people are making important decisions. So don't use no lock unless you know exactly what it does, because most people don't, and you know exactly what it will do to your result set. Same thing, well, actually it's not the same thing, but a similar issue here with set no count on. Now I actually do use this in all of my code as the first executable Transact-SQL statement in my stored procedures. And what set no count on does is it turns off the done in process, the done in proc message. And so what that means is the code, so we have 31 instances of this, and we have a number of statements here that we can see that have no set no count on. The more iterations you have in your T-SQL code, the more time it takes, because SQL Server by default, even if it's like, let's say, set this particular variable to a value, behind the scenes, SQL Server has a done in process message that it sends to itself. It's like, hello, Miss Piggy. Hello, Kermie. You know, and it's like, did you assign my variable? Yes, I assigned your variable. You know, did you loop through the cursor number 1? Yes, I would. And so it just, so like if you have a cursor that goes through 50,000 rows, you have 50,000 done in proc messages. And in some testing I've done in another session I call 10 things every SQL developer needs to know, I show empirically that, you know, it goes from 16 seconds to 8 seconds or whatever that number is. And with each release of SQL Server, it has gotten much better at that. The improvement has gotten less extreme over time. But if you don't put this in your code, you're having all of this chatter happen behind the scenes that's never even presented back to the human eye. So why not turn it off in the first place? Okay. So again, we'll look for temp tables. We'll look for hints that are sitting in the in those modules without actually necessarily being executed at this point. So again, we got 5 minutes left now. So 6 minutes, all right. Let's see if we can hurry on through this. Another thing I like, and this is just because I'm a little bit OCD about things like standardization and naming and so forth. So this is a particular set of code that will look at everything that is in your modules, and it will tell you if we have misnaming happening, where the name and the data type of columns are not matching one another, the modules are not matching one another. And so we can see if there is an issue with each of these different, maybe as it says here, it has a reserve word in the title. There's a couple more that I want to show you very quickly too, and I'll open these all at once. Okay, all right, we got those last few moments here. So I mentioned in passing implicit conversions. So there are a number of data types that seem like they should work together just fine, right? SQL Server is going to process these, and there's going to be no difference in performance, even though we've used different data types throughout. The problem is that's not true, and it's not true at a binary level typically, okay? So we have 3 executions of essentially the same statement, but because I have put a quote in the second one and an in apostrophe quote in the other, so this is a number, this is an integer, I'm sorry, this is a text, varchar, and this is a in varchar, they all worked, no problem. But if we look in the, I'm going to go ahead and skip down here to the, to see what we have happening. I'm sorry, I need to re-execute this because I need to show you with the execution plan. They look like they're going to be fine and they're going to be identical. All right, now that we have execution plans turned on, so it took a moment or two longer, but when we look at the execution plans here, 37% of the processing was devoted to the first query, and we have index scan and a key lookup, which indicates there's a problem. I couldn't fully find the record I needed easily. Now we have an index seek when we use a varchar and a key lookup. And then finally, we have a very different looking one as well here with the index seek and the key lookup. So notice that that first one, because it was in a contradictory data type, we get a scan, not a seek. So we have to look through all the values in that index, okay? So this is a particular set of code that will find mismatches between the in the modules, right? So this is code at rest right here. So it will find those data type mismatches between 2 columns. And it's a bit expansive. It looks at not just the data type, but you know, if you say varchar 30 and another one is varchar 128. So it tells you when 2 columns or a column appears in 2 or more tables when they are different from one another, so you could see if they were aware of that possibility of causing implicit conversions. All right? There's also a couple more queries here about foreign keys. It's very common to see in database design, a table is created without foreign keys. Maybe it has a primary key, clustered index, doesn't have foreign keys, but it has index columns that should be a foreign key. And you need to make sure that there are both foreign keys and that you have applied a non-clustered index to those, because they don't go hand in hand. But they do on certain platforms, and so if that person is used to using a different platform than SQL Server, they are naturally expecting SQL Server to also put a non-clustered index on a declared foreign key. And that's a problem. Another bit of code that's in here will tell you if you have overlapping indexes. So I have these 3 columns in both of these indexes. Well, you don't need a second index because those 3 columns are going to be the same. All right. So we're out of time in terms of the demos. There's a lot more queries in there for you to look at and experiment with. So I hope that has been interesting to you. Let's jump back to the slides. Yes? Right. So the question for those on the line, watching as we go, are these available? Yes, they're available on my blog at thwack.solarwinds.com. Funny name. Of course, if you want to email me or connect with me online, I'm on all the social media sites at K.E. Klein. So drop me a note and I'll send you the very latest, which will include the corrections of finding those percent. Thank you, friends, for improving my code. Feedback is a gift. And so if you have constructive criticism, if you have comments or questions, love to hear from you. If you have complaints, my name is Erland Sommerskog, and so you can send all your complaints to my buddy Erland. Also, we have, and then he would forward them to me, exactly. So we have a great free tool called Plan Explorer. I'm actually going to talk about this a little bit later. And we just dropped a new release. So there's some new features in it if you've used it in the past. It has many hundreds of thousands of users. So I hope you'll take advantage of that. We're going to appear in London in May. So if you are a SolarWinds user, I encourage you to go. You'll get a nice lunch and a lot of training, exposure to our experts, other experts in the company. And if you haven't ever heard of us, please come by the booth. We specialize in database and infrastructure monitoring tools and have some of the best for database monitoring in the business. So I hope you'll give us a chance. With that, I want to say thank you. I appreciate your time. I'm very grateful that you've carved out a minute to ignore the other wonderful sessions happening and spend it here with us today. So folks, thank you very much. I appreciate it and hope to see you at one of my other sessions. Thank you.